I know what you're thinking. Not another episode on the mini-Centurion. I am so sick of seeing this thing. And if you're not thinking that, I am. I'm definitely thinking that. I hate doing multiple episodes on the same topic in a row. I have to cycle through topics or I start to burn out on something. And this machine is getting dangerously close to burning me out on it. But the schedules this month did not line up politely. As you watch this, I am currently in Dubai.
So hot. So hot.
But either way, I can't work on this machine while I'm spending 10 days on the other side of the planet. So I have to get it done now, because when I get back from Dubai, I have less than 6 days before VCF Southwest. So I gotta finish it now or else I'm gonna make it worse while I'm trying to work on it with jet lag. So we're hunkering down and we're getting it done. And we were so close in the previous episode. We just had a fixed platter that was unreadable by the operating system because the previous owners, the dealership in Cincinnati, had removed the .format command, so we can't low-level format that platter. And I said, we'll just write a little piece of code for it. I won't show it on camera because it'll be super easy peasy. And it so wasn't easy. Assembly is hard, man. Assembly is so hard. It took me like 9 days, and I'm still not sure if it'll work. So that's what we're gonna do today. We're gonna try and get my broken ghetto assembly to low-level format the fixed platter. Oh, I hope it goes well, because I get on an airplane like the day after tomorrow. So what does it take to low-level format a disk when you don't have the proper tools to do it? Well, you gotta write an assembly program that runs bare metal, and that's essentially what we've done here. So we're gonna start the program pretty simply by just showing some opening text using a routine called print null. So you can see that the text is right here, and we jump to a subroutine called print null, and then after that we have define byte 8C, define character, hawk format program, 8D, 8A, Centurion counts top down, etc. So the way that the print null subroutine works, it sticks a bunch of stuff into the stack so it can be used later, and then it does a pretty interesting trick with the X register. Whenever you jump to a subroutine, the return vector for coming out of that subroutine is stored in the X register. So we're actually just looking at what our return vector is pointing at, and we haven't put any instructions there. Instead, we put the characters that we want to print. So we grab that character, we wait until the mux is ready, we stick it in the mux, and then we loop back up and increment the X register to the next address and grab the next character, and we repeat this cycle until we get a 0, 0. And when we get a 0, 0, we know that we're empty. Once we return from that, we go to the next step here, which is to fill 400 bytes of memory with X, 0, 0. Now the reason we choose 400 bytes is because the Centurion uses 400 bytes per sector for reasons. So our subroutine here is pretty simple. It just creates a little loop that fills a section of memory with 400 bytes. Once we're done with that subroutine, we jump into the next block here, which is unit setup. So we're actually waiting for a numeric input from the user. They're gonna hit a button from 0 to 7. And when they do, we're going to look at just the low nibble because we need to convert that ASCII to an actual hexadecimal value. But if you're doing numeric values 0 to 9, it's quite easy. You just ignore the high nibble. And so we look at just the low nibble and we stick that into the MMIO address F140. This is the platter select address for the disk controller cards. And then we need to convert that nibble to a different format because reasons, again, gotta love Centurion. But once we convert that to a different format, we stick it into F143, which enables the write bit mask and actually allows us to write stuff to the disk. Once that's over, we do a quick RTZ. This just sends the heads all the way out to cylinder 410 and then counts backwards to 0. That's the easiest thing to do. We just stuff 03 into MMIO address F148. Then we get into the meat and potatoes of the actual format here. And we need to do a bunch of interesting things. We need to set the DMA device to 0. That selects the drive we're working on. We need to enable DMA, and then we need to load the location of where the bytes are in memory into the DMA address register. Then we need to tell it how many bytes to count. And then we're gonna load that into a DMA register as well. And now the DMA is completely set up for the drive to go off and do its own thing. So we just load a 01 and stick that into MMIO address F148. That is a write command, and it kicks off the entire DMA, and the DMA will do its thing until it's finished. And then we just need to increment it to the next sector, which we do in this increment subroutine down here. All we're doing is loading up our current track, loading up what the end track is going to be, comparing them, and if they're the same, then we're done. And if they're not the same, we need to increment by 1, loop all the way back up to here, and run the format loop again. Once we're finished, all we really got to do is just print goodbye on the screen. So it seems... I don't know, when I explained it here, it seems really easy, but it took me like 10 days to figure this out. It was an absolute nightmare. Hopefully it works. It works in the emulator, but there's only one way to find out, and that's to load this program into the actual machine and see what happens. All right, in order to get this program onto the Centurion so we can run it and format the platter, I'm just gonna use the diag card and the memory monitor. I compiled or assembled the program on the emulator on the PC, and then I extracted the hexadecimal out of it, and then all I need to do is take that hexadecimal and just dump it in through the memory monitor on the diag card. And you can see me doing that here with teraterm. And with it fully dumped in, that looks correct. So we'll move back over to the main terminal here, and after checking, you can see, yeah, M0200, 9080005F, 80C5, that all looks correct. So all we got to do now is run it. So we just do G0200. Ooh. Oh, this is a good start. Hawk format program, Centurion counts top down. Platter 0 is drive 0 removable. Platter 1 is drive 0 fixed. We want to format the fixed platter, so we're going to do platter number 1. As soon as I press this, it should start going. How come it only did one sector? It's like midnight. I've been going hard at this for at least 12 hours, and there's a thunderstorm rolling in. This is it. This is the last shot I get at it today before I gotta just shut it down and try to get some sleep. The reason I'm going so hard on this is that I'm on an airplane in less than 30 hours, and if I don't have this going before I leave the country, there's a solid chance it may not get going before VCF Southwest. So this, I hope, works. But I've been in this seat, I've made this speech to this camera at least 6 times before, and none of that footage is going to get used because all of those revisions were not functioning. So I'm skeptical, but cautiously optimistic. So let's give it a shot. I've got the program loaded into the memory monitor here. All we got to do is type G0200, hit new line. Oh, please work. Please work. All right, let's hit 1. That is the most promising it has ever been. It is so much slower than it's ever been in the past, which tells me that it's actually finally properly formatting the disk. Oh, please let that be the case. Oh, come on. This is gonna take a while, I think. Well, it got to the end in an interesting fashion. Everything went perfectly until it looks like the last 2 or 3 cylinders. We got lots of fails here. Now, the multiple X's doesn't mean that each X is a single sector. You really only count the dots, and X means that our check ready check failed in some way. So these final few, looks like maybe 32 sectors here, which is probably just the last cylinder, didn't seem to work right, but that should not matter at all. We should be able to go into the operating system and actually see the disk now. Final words here, either it went perfectly or it failed dramatically. Regardless, I quit. Flip the table. There's not a table in here I can flip, but hopefully it went perfectly. So let's push the reset button. It says D equals here. We'll do H0 to boot into the removable platter. We did our 3 RTZs. That's good. We want to do S equals 0 here. We'll hit enter, enter. 082489. Here comes the moment of truth. We do a .sta. Oh, it's not all stars. It's not all stars. I think that means good things. Let's do a .no guard on 1. It actually did it. That's the first time it's ever done that. Okay, let's do .clr1, comma, volume equals Usagi. It did that too. If I do, next we'll do s dot loader on 1. Okay. Volume Usagi has a new loader. Look at that, it shows up. 1 is Usagi. If I do a .dir1, 2 tracks used, 808 available. That disk is now usable in the operating system. We have just one more operation to run. S.dump. Source disk is 0. Target disk is 1. Do I want to check volume dates? No. Do I want to check volume labels? No. Print device will be CRT 0. Ready? Yes. So this is probably going to rename my volume from Usagi to system. That's totally fine. But what it's doing is it's copying every single file from the removable platter down to the fixed platter. We are making a perfect backup of that removable platter onto the fixed, which is fitting because the removable is a perfect backup of the fixed originally. So this means that we always have the removable platter to back up down to the fixed, and now we can play around and mess around and do all sorts of crazy stuff on the fixed. So all we got to do now is just wait for this to finish. This is so exciting. What a day. What a day. No errors. Do you want to guard the target disk? No. Do you want to no guard the source disk? No. Every time it seeks, the whole cabinet shakes. If I do a dot status, there we go. dir1, that is all of our files on 1. So here's the real test. Let's escape out of that. I'm going to push the RF switch in, I'm going to hit the opposite button, and we're going to try and boot from the fixed platter. H1. 3 RTZs. System disk equal 1, we're just going to hit enter right on that. 082489. Exec ready. we just booted .sta. We just booted off of the fixed platter. The amount of effort it took to get here was ridiculous. I'm going to bed. I'm just gonna go to bed. That was awesome. So what went wrong? What was it that was incorrect in my code that kept me at my wit's end for 12 hours straight yesterday? Well, it turns out it was just two simple mistakes, and a good programmer would have found them and squashed them in a matter of minutes, but life is tough when you're dumb. So it took me 12 hours. But the first mistake was something that seems painfully obvious as soon as you realize it. I was going through and setting up the DMA exactly as I was supposed to, but when I got to the end of that DMA string, I told it to write 400 bytes of 00 into the sector address. But we don't have a sector address yet. We haven't set that up. We need to low-level format it. We need to lay down all of the preamble and postamble stuff that is not the data itself. And it turns out that there's actually a proper way to do this, and it's to use the MMIO input 06 then 05 into the address F148 instead of 01, which is just a simple write. 06 and 05 actually write down new preambles that include the sector address and all of the other bits that are important, and a postamble for that as well. It also writes down whatever bytes you tell it by setting up the DMA. So we don't need to do a separate 01 to write 400 bytes of 00. That 0605 does it for us. The second mistake was when I was checking to see whether we were on cylinder and things had gone well, I was ANDing a result coming in with 00. And if you AND anything with 00, the output is always going to be 00. So my code was thinking that the drive was just immediately ready all the time at like every 200 nanoseconds because it wasn't checking anything. So we were just flat overrunning the drive. And the reason that we were getting interesting problems like the fault light coming on is that the drive couldn't keep up. So it was seeing things like both the write heads being selected at the same time, or not being on cylinder but a write gate being sent. So it was just getting a whole bunch of confusing signals coming from the machine, and it was just going, I quit. So once I figured out how to rectify that, it turns out I didn't even need to AND it with anything. Just doing the loading into a register sets the flags, and so we can just check if it's 0 from there. So it was a super easy fix, but I was not intelligent enough to see it. And a bunch of people in the Discord helped get me through this. Rin and Gecko and Mesaka lended unbelievable knowledge of the Centurion itself. Of course, Ken Romaine came in with insane knowledge of how the MMIO works. MX Shift started learning Centurion assembly to specifically help me with this problem, and within like a matter of days, he's better at it than I've been by looking at it for months. So that's the difference between a smart person and a dumb person. And then we had Philip and so many other excellent people in the Discord that were jumping in to help me figure out this format program, and we got it figured out. We have almost a fully working Hawk drive. The removable platter is read-only, and that contains our backup disk. The fixed platter is read-write, so we can do all manner of dumb stuff on the fixed platter, and if we blast holes in the operating system, it doesn't matter because we can copy the removable platter right back on down to the fixed with no worries. This drive is working as best as I could have hoped for, and it's gonna be perfect for VCF Southwest. So I want to thank you all so much for watching, and I hope to see you in the next episode.